In the deep silence beyond Neptune, the Voyager spacecraft kept moving, gliding through a darkness no human eye had ever seen. It was supposed to find nothing there, only empty space and cold dust. For a moment, NASA scientists thought there must be an error, because how could a region so cold suddenly burn like a star? To understand the wall, we must first understand the journey. When Voyager 1 and Voyager 2 left Earth in 1977, their goal was simple: explore the outer planets and show humanity what lay beyond the reach of our telescopes. Each spacecraft carried a camera, a handful of instruments, and a golden record filled with images and sounds of life on Earth. No one expected them to still be alive 4 decades later, drifting far past the worlds they were meant to study. The mission began with a rare alignment of the outer planets that happens only once every 176 years. This allowed the spacecraft to use the gravity of each planet to slingshot toward the next one, saving time and fuel. Voyager 1 flew past Jupiter and Saturn, sending back images that changed how we saw those giant worlds. It captured swirling storms on Jupiter larger than Earth itself, and the glowing rings of Saturn shining like ice in the darkness. Voyager 2 took a longer route, visiting Uranus and Neptune, becoming the only human-made object to ever see those distant blue planets up close. After those encounters, both spacecraft faced a choice written not in commands but in destiny. Stop transmitting or keep going into the unknown. NASA decided to let them drift outward into a region no human mission had ever entered. Beyond the orbit of Neptune, the Sun still ruled space through its invisible power. That power came from the solar wind, a stream of charged particles flowing outward in all directions. These particles created a vast bubble around the solar system called the heliosphere, a kind of magnetic shield that protects Earth and the planets from the harsh radiation of deep space. But like any shield, it had an edge, a place where the solar wind slowed down and met the gas between the stars. That border was called the heliopause, and it marked the true frontier of the Sun's influence. For years, scientists could only guess what waited there. Some imagined it as a calm boundary, a gentle fade into interstellar space. Others believed it was more like a storm, where the Sun's energy collided with galactic particles to form an unseen barrier. Voyager's instruments were built to find the truth. They measured temperature, plasma density, and magnetic fields as they traveled farther from home. Slowly, the signals grew weaker, but the data kept coming, every byte traveling billions of miles to reach the antennas on Earth. By the early 2000s, both spacecraft were near the edge of the heliosphere. Their sensors showed the solar wind beginning to lose strength, a sign that they were approaching something new. The energy that once pushed outward from the Sun was now being pressed back by the interstellar medium. In simple terms, the wind of our star was running into the wind of the galaxy. The collision of those two forces would soon reveal what no one had ever seen. For NASA, this was more than exploration. It was a chance to step outside the cradle of the Sun and look at how our solar system breathes within the galaxy. Every measurement Voyager made brought us closer to understanding the invisible wall that separates our world from everything beyond it. But what would happen when the wind finally stopped and the spacecraft crossed that invisible border? Would they find silence or something alive and burning in the dark? For decades, scientists believed that the solar wind would eventually fade into nothing, dissolving quietly into the emptiness between the stars. But as Voyager 1 continued its climb into the outer darkness, the instruments on board began to sense something strange. The stream of charged particles flowing from the Sun was no longer steady. It weakened, then fluctuated, as if the wind itself was struggling to breathe. The solar wind is a constant flow of high-energy particles that forms an invisible shield around the solar system. It protects Earth from cosmic radiation and carries the sun's magnetic field far beyond the planets. Without it, our solar system would be exposed to the violent radiation of the galaxy. As Voyager moved farther from home, it began to record the limits of that protection. The wind that once rushed outward at nearly 1,000,000 miles per hour started to lose its strength. At some point, it simply stopped. The data shocked NASA's scientists. They realized the spacecraft had reached the border where the sun's power met the pressure of interstellar space. In that moment, Voyager crossed into a region where two cosmic forces collided, the solar wind pushing outward and the interstellar medium pressing in. It was a battle that had been going on since the birth of our solar system, and Voyager had finally reached the front line. The instruments showed a sudden rise in plasma density, while the speed of the solar wind dropped to 0. This meant the particles from the sun were being trapped and compressed by the gas between the stars. It was like watching the ocean waves crash into a frozen shore, a slow-motion collision of unimaginable scale. Scientists called this area the termination shock, the first sign that Voyager was leaving the calm of the solar system and entering a new sea. Even at such great distances, the spacecraft was still connected to the sun by a faint magnetic thread, a reminder of where it came from. As Voyager moved deeper into this strange region, the instruments picked up bursts of radiation that pulsed through the plasma around it. Each pulse revealed that the spacecraft was entering a zone of intense turbulence where the forces of the sun and the galaxy twisted together. The data suggested that this border was not smooth or stable. It changed with the rhythm of the sun, expanding when solar activity was strong and shrinking during quieter periods. The edge of the solar system was alive, breathing with the heartbeat of its star. For the scientists on Earth, every new signal felt like a message from another world. The readings told a story of pressure, heat, and motion, a place where the sun's influence finally faded. Voyager had gone farther than any human creation in history, and still the unknown waited ahead. But then came the most surprising discovery of all. When the instruments were adjusted to measure plasma temperature, the results made no sense. The numbers spiked higher than anyone could believe. Had Voyager reached the true edge? Or had it just touched something no one had ever imagined, a wall of fire? When the data from Voyager 1 reached NASA in 2012, scientists thought their instruments were malfunctioning. The readings showed a sharp rise in plasma temperature, reaching almost 50,000 degrees. Nothing in space that far from the sun should ever be that hot. Yet the numbers kept coming, clear and steady, proving it wasn't an error. Voyager had crossed into a zone of superheated plasma that no one had ever predicted. This region was not made of flames like those on Earth, but of particles moving so fast they carried enormous energy. As the solar wind from the sun crashed into the thin gas of interstellar space, the two streams collided and compressed. That collision produced extreme heat, forming a glowing boundary that scientists began to call the Wall of Fire. It wasn't a wall of matter, but a boundary of pressure and energy, marking the end of the sun's influence. Voyager had not only seen it, but had gone through it, something no human creation had ever done before. Inside this mysterious barrier, the plasma around the spacecraft thickened nearly 40 times compared to the empty space behind it. At the same time, the speed of the solar wind dropped almost to 0, showing that Voyager had left the flow of the sun's breath and entered a new ocean of energy. Every particle detected there told a story of two worlds colliding, the inner world ruled by the sun and the outer one shaped by the galaxy. Even though the spacecraft was now more than 11 billion miles from Earth, it still carried the sun's magnetic signature. The energy of our star reached farther than anyone had ever imagined. Voyager 2's crossing 6 years later confirmed that this was not a random event. Both spacecraft recorded the same spike in plasma temperature, the same slowing of particles, and the same shift in magnetic direction. These twin discoveries proved that the wall of fire is not just a strange occurrence in one place. It is a permanent feature, an active layer where the solar wind is stopped, squeezed, and reborn as it meets the pressure of the Milky Way. NASA compared the process to a shock wave from a speeding ship cutting through water in front of turbulence that glows with invisible light. For the first time, scientists could measure the sun's true border. The heliosphere was no longer just a theory. It was a living, breathing bubble whose edge burned with cosmic fire. This discovery changed how we see our solar system, revealing it not as an island of calm, but as a storm of energy surrounded by the sea of the galaxy. The wall of fire was proof that the boundary between stars is not silent but alive, shaped by the eternal struggle between light and darkness. But if the sun's edge burns this hot, what could that mean for the other stars scattered across the galaxy? Could every system have its own wall, its own fiery border keeping the universe apart? Or are we the only ones surrounded by flame? Voyager's discovery of the wall of fire changed everything scientists thought they knew about the edge of our solar system. For decades, the outer boundary of the sun's reach had been seen as cold, dark, and still. But the data proved that it was alive, filled with motion, energy, and heat. It was not a dead frontier. It was the sun's final breath before fading into the galaxy. Inside this fiery boundary, Voyager found that plasma didn't just flow, it pulsed. The readings showed that the edge of the heliosphere expanded and contracted like a living lung. When the sun grew more active, the solar wind pushed harder, stretching the heliosphere outward by billions of miles. When the sun quieted down, the pressure dropped and the bubble shrank back toward its center. This breathing pattern meant that the outer layer of the solar system was not fixed at all, but constantly changing with the heartbeat of the sun. NASA scientists compared this to the bow wave of a ship cutting through the ocean. Just as water piles up at the front of a moving vessel, the plasma at the edge of the heliosphere builds up under the pressure of the galaxy's interstellar medium. The faster the sun's wind moves, the greater the compression. Every burst of solar energy travels outward for billions of miles, shaping the invisible bubble that shields the planets inside. The wall of fire, therefore, is not just a wall, it is a mirror reflecting the sun's pulse, a living barrier that grows, shifts, and flickers with time. What made this discovery even more fascinating was its rhythm. Voyager's sensors recorded waves of energy moving across the boundary like ripples on water. Each ripple carried the story of solar flares, magnetic storms, and eruptions that happened years earlier on the sun's surface. It was as if the heliosphere itself had memory, echoing the sun's past in the language of plasma and light. This realization showed that our solar system behaves more like an organism than a machine, with every part connected through invisible threads of magnetism and heat. Scientists now believe that this dynamic edge plays a vital role in protecting Earth. By pushing back against cosmic radiation, the heliosphere acts as a shield that makes life possible. Without this layer of fire, the constant rain of galactic particles would strip away our atmosphere and expose the planet to deadly radiation. The wall of fire may look violent, but it is the reason we can exist in peace beneath the sun. It is both a barrier and a lifeline, balancing destruction and protection in perfect harmony. The more Voyager revealed, the clearer the truth became. The edge of the solar system is not silent. It burns, it breathes, and it moves in rhythm with its star. What seemed like a boundary is really a living frontier. Proof that the sun is far more than a ball of fire. It is a system that feels and reacts. But if the sun's edge can move and change, could it also communicate? Could the patterns of its energy be signals, not accidents, messages carried through the fire itself? For decades, scientists believed that once Voyager crossed the wall of fire, it would leave behind the Sun's magnetic field completely. The outer space beyond the heliosphere was thought to be dominated by the galaxy's own magnetic forces, running in an entirely different direction. But when the data came back, the results defied everything they expected. The magnetic field outside was not opposite. It was almost perfectly aligned with the one inside. This discovery shocked NASA's research teams. It meant that the boundary between our solar system and interstellar space was not a sharp wall at all. Instead, it was a smooth transition zone where magnetic lines from the Sun and the galaxy wove together. Voyager had entered a place where the two fields touched and tangled like threads in a single cosmic fabric. It was a handshake between two magnetic worlds, one born from our star and one stretching across the Milky Way. To understand how strange this was, we need to remember how magnetic fields work. Every star, planet, and galaxy has its own field, invisible but powerful. These lines of force guide charged particles, shape radiation, and even influence how cosmic dust moves through space. Normally, when two magnetic regions meet, they twist and oppose each other, creating turbulence and heat. Yet at the edge of our solar system, that didn't happen. The fields seemed to merge peacefully, forming a bridge instead of a barrier. Voyager's magnetometer recorded this connection in detail. The instruments showed that the direction of the magnetic lines outside the heliosphere was tilted only by a few degrees compared to those inside. That small angle was enough to prove that the boundary was more like a soft gradient than a break. It also explained why the plasma in that region moved so smoothly. Rather than colliding violently, it flowed from one side to the other, exchanging energy in a quiet equilibrium. This discovery changed how scientists understood our place in the galaxy. It suggested that the Sun's influence does not simply end, it fades gently into the larger field of the Milky Way. Our solar system isn't isolated, it is part of a vast web of magnetic currents connecting stars, nebulae, and dust clouds. The magnetic handshake Voyager detected may help explain how cosmic rays enter the solar system and how stellar winds interact across space. It could even reveal how life-supporting systems remain stable in such a chaotic environment. For NASA, the finding carried a deeper meaning. It was evidence that the Sun is not alone in its power. Every star is part of an unseen network, bound together through magnetic bridges that span light years. Voyager had not just crossed a border, it had found proof that the universe itself is linked through invisible energy. The Wall of Fire, once thought to be a shield, was now understood as a connection between the Sun's world and the galaxy beyond. But if these magnetic lines really connect the stars, what might they carry between them? Could information, energy, or even matter flow through those unseen threads, linking distant systems in ways we have yet to understand? The heliosphere, once thought to be just a bubble of solar wind, is now understood as Earth's first and greatest shield. It stands as an invisible wall, protecting our planet from the violent radiation that fills the galaxy. Without it, cosmic rays would constantly bombard the atmosphere, breaking molecules apart and stripping away the ozone layer. Voyager's journey proved that the heliosphere is not just a border, it is the thin line between life and extinction. Inside this protective bubble, the Sun's magnetic field acts like armor. It bends and redirects most of the high-energy particles coming from deep space, but the discovery of the Wall of Fire revealed how delicate that protection truly is. At the edge, where solar wind meets the galactic medium, only a small portion of radiation seeps through. When the Sun is active, its magnetic field grows stronger, pushing back most of the danger. When it weakens, more cosmic rays slip inside, altering the radiation balance across the solar system. Voyager's measurements helped scientists understand this process in real time, showing how solar activity directly shapes the safety of our world. For space exploration, this knowledge is critical. Astronauts traveling beyond Mars will no longer be protected by Earth's magnetic field. They will depend entirely on the heliosphere to shield them from deadly radiation. The data sent by Voyager allows NASA to predict when the cosmic shield is weakest, helping future missions plan their journeys through safer windows. The spacecraft showed that this barrier breathes and flexes, expanding and shrinking with the heartbeat of the Sun. When it expands, human missions are safer. When it contracts, the solar system becomes exposed to the galaxy's harshest storms. What makes this discovery profound is its universality. Every star has its own heliosphere, a protective bubble made by its stellar wind. By studying ours, NASA gained a model to estimate which exoplanetary systems could support life. If a star's wind is too weak, its planets are left open to cosmic radiation. If it is too strong, it could strip away their atmospheres completely. The balance we live under is rare and fragile, a cosmic coincidence that may decide where life can exist in the universe. Voyager's findings turned the idea of the Sun from a solitary source of light into a guardian of life. It revealed that we are not just living under its warmth, but inside its protective reach. Every sunrise on Earth begins within that shield, inside the breath of a living star. But what happens when this shield fades, or when our Sun grows old and silent? Can life survive beyond the safety of its cosmic fire? Voyager's discoveries did more than redefine the edge of our solar system. They gave scientists a key to understanding how other stars might protect their own worlds. The heliosphere was no longer just about us. It became a model for how life could exist elsewhere in the universe. Every star generates its own bubble of energy, a kind of miniature heliosphere called an astrosphere. These bubbles shape the fate of the planets inside them. If the stellar wind is strong enough, it forms a shield that blocks deadly cosmic rays, giving planets a chance to keep their atmospheres. If it is too weak, the radiation from deep space strips everything away, leaving worlds barren and lifeless. Voyager's journey allowed scientists to compare the Sun's protective reach with the possible shields of other stars, helping them guess which systems might be able to support life. NASA's data revealed that the Sun's heliosphere is unusually stable for a star of its age. Its shape, balance, and rhythmic expansion suggest that it is finely tuned, strong enough to protect, but not violent enough to destroy. This delicate balance could explain why Earth has remained habitable for billions of years, while other planets never stood a chance. By studying the wall of fire and the living edge of the Sun, researchers began to look at the heliosphere not as a random phenomenon, but as part of the reason we exist. The Voyager missions also inspired plans for future probes designed to go even farther. NASA's proposed interstellar probe would travel 3 times beyond Voyager's distance. Equipped with sensors capable of mapping the heliosphere's full shape and detecting the magnetic and plasma structures of nearby stars. This mission could finally show whether every star has its own wall, or if our Sun's fiery border is something truly unique. It could even help explain how energy flows between stellar systems, how the galaxy breathes and evolves over time. But the deeper meaning of Voyager's message lies beyond science. Its faint signals still reach Earth from billions of miles away. Proof that our voice can travel through the dark. Each bit of data is a whisper from the edge, reminding us that the boundary of the Sun is also the beginning of the stars. Voyager showed that our solar system is part of a grander rhythm, connected to the galaxy not by distance but by energy. And as we prepare to send new explorers beyond its path, one question remains. If our Sun's voice can echo across the stars, what other voices might be waiting to answer? Voyager's mission began as a journey to study the planets, but it became a message from humanity to the universe. It showed that the edge of the solar system is not an ending, but the start of something greater. Somewhere beyond the wall of fire, our 2 silent explorers still drift through the dark, carrying the voice of Earth across the stars. If the sun's boundary burns with life, then what other fires might be waiting beyond? If this story moved you, don't forget to like, share, and subscribe for more mysteries that push the limits of what we know.